problem number 23, and I am not going to lie to you. What did I do there? That's not a 3, that's supposed to be a 3. There you go. I'm not going to lie to you in terms of I would have never, I couldn't have done this without looking. I looked. Sorry. I just so could have never done this. First of all, you can't just say the common ratio is less than 1 so it converges. It actually doesn't converge, and it doesn't even have a common ratio. It's not a geometric series, right? Because if you look, the common ratio between 1/2 and 1/3, the ratio, not the common ratio, but the ratio between 1/2 and 1/3 is 1/3 divided by 1/2, which is 2/3, right? And then the ratio here between 1/4 and 1/3, that ratio is going to be 1/4, right, divided by 1/3, which is going to be 3/4. So I mean, it doesn't even have a common ratio. So you know, it can't converge. We can't use our convergence formula or anything like that because of that. Now, can we show that it diverges? Let's look at what happens here. So I think what we're going to do is actually compare it to a series. We're going to try to make this into a geometric series, or at least come up with a geometric series that it's similar to, and then we're going to show that that series does not converge, it diverges. So let's start by doing this. We're going to take 1/2 plus, and then we're going to group the 1/3, okay, and the 1/4 together. We're going to group those together, and then we're going to group the 1/5, the 1/6, the 1/7, and the 1/8 together. Those 4 terms together, and then we're going to group. And we're going to group the next ones: the 1/9, the 1/10, the 1/11, the 1/12. This is so clever. Never would have come up with this. Okay, let's see. 1, 2, 3, 4, 5, 6. The 1/14th. The 1/15th. Oh no, I can't fit the last one in. We're going to put it right there. The 1/16th. Plus dot dot dot, and we're going to keep going like that. Okay, now here's the clever part. The very, very clever part. Actually, it was pretty clever to do that too. But then, okay, now this isn't going to be equal to, but it's definitely, this series right here that I have written down is definitely going to be greater than this series right here. Do you see? Look at what I'm going to do. Okay, 1/2 is going to stay the same, but now I'm going to replace this 1/3 with a 1/4. 1/3's larger than 1/4. Right? So therefore, you know, so far, if I wrote everything else the same, that this one would have to be smaller. This series right here, this one would have to be smaller than the one above it. Okay. Plus, and now right over here, I'm going to replace all 4 of these with 1/8, because then if you see here by doing this 1 plus this 1/8 plus 1/8, do you see what I really get there when I add those together? I get 4/8, which is 1/2. So I get 1/2 plus 1/2 plus 1/2. Do you see? I'm just adding 1/2 together. And then now remember, 1/5 is larger than 1/8, and 1/6 is larger than 1/8, and 1/7 is larger than 1/8. So because of that, I replaced all of this with smaller numbers. Right, 1/8 is smaller than a 5th. 1/8 is smaller than a 6th. So anyway, I could still keep this inequality here. All right, so doing the same thing down over here, I'm going to get 1/16 plus 1/16, replacing the 1/9 with 1/16, the 1/10 with 1/16, smaller fraction. Replacing all of these with a smaller fraction. So you can see this number, whatever this series diverges, or whatever this series does, and what we're going to show you here is this series doesn't diverge. 1, 2, 3, 4, 5, 6, 7. Take it again. 8. All right. So all of these right here. And this is 1/16 right there. Okay, all of those can this plus, and then of course, you know, it would be the next group right there, plus dot dot dot. It would keep going, and all of that is going to have to be then greater than or well, let's not say greater than, because now this is going to be equal to 1/2 plus, and a fourth is 2/4, which is 1/2, right? And then all of those grouped together to become 4/8, which is 1/2, 8/16, which is 1/2, and so you can see this is really just going to be 1/2 added together an infinite number of times. Now this is a geometric series, and we can see the common ratio of this geometric series is 1. The common ratio is 1, and so therefore this diverges. Because that common ratio of this series here, if this smaller series diverges, then this larger series right here is this even larger one's going to have to diverge. All right, so that's it.